All right, so I am going to show you from the beginning how to create this. So hopefully, yeah. So basically, it's an ASCII art thing. It's also gonna show you how to basically these are a bunch of spheres, and it's gonna show you how to object orientatively create like a sphere that holds state, and yeah. So let's get started. First off, we'll want to get things prepared to do stuff. So I have gone ahead, and here's my homework like I was talking about today. And this is my JavaScript thing, my folder, where I'll hold most of my stuff so that I can just inside of here, if I open this up, oh, it's actually going to open up in there, no. So I want to open it up in here, and I can just say /js/3min.js, and then access these files directly. Where you're going to find these files is not clearly, they didn't start out in this JS directory. If you go to 3js.org, and the web sucks here. Well, basically, if you go to 3js.org, there's a downloads. Whenever you download it, it will create a directory like this, 3.js. The build has 3min.js. Again, min and JS are the exact same thing, except all of the white space is gone from min. So it's been minified, basically. And that's just something to help your browser load in data faster. But if you look around, you can see that there's a lot of source material. It's all this JS. And it's basically all inside of the 3.js, but these are the core libraries, and this is the build, basically all of the stuff put together into one. There's also all of the examples, which we're using this example today. If it loads in correctly. Maybe it will, maybe it won't, who knows. Oh, I must have taken this out accidentally. So be careful whenever you're going through, because inside the examples you'll find for instance, you'll find in libs the stats, which we're not going to really go into today. It's just basically showing you what the frame rate is, and you'll find the effects, which here's the ASCII effect, and you'll find the utils. Let's see, where is it? And my computer's running slow. Oh, controls. So this is where usually whenever you download it, that'll be where your trackball control is, but I've already moved it. So again, you can see, go into the homework, and then in JS, I pulled in trackball controls. I pulled in 3min.js. I'm going to actually get rid of this because that's an old thing. And then I also pulled in ASCIIeffect.js and statsmin, but we're not going to even use it. That was just part of the lesson. So how do we start? Well, first off, we go into here. We make a new folder or a new thing. And if we just hit Apple S, it'll bring up the save. And we'll say, for me, I'm going to say example 2 because I've already done this just so I could go through. But you can say example 1 or example anything. And then you save it. Down here it should change this to HTML, which is good. I'm not really going to talk about too much HTML, but there are some things that you'll see in a lot of the examples. You'll see a head, and inside the head you can you can do title, and you can title your thing My Awesome 3.js site. And if you save that and open it in the browser away, it will up here say my awesome3.js site. So, you know, it's basically tags that are showing you like in between these tags, between the opening and the closing, if you put something in it, it will know what to do with that. Next, we'll want to create body, which is basically the body of our website. And here, we'll talk about a new tag called, or not new, I've kind of talked about it a bunch, but it's the script tag. So the way that you include Three.js is actually, you need to tell the browser, hey, where is this? Well, I've put it in my JS folder, which is one folder back and inside the JS, and then 3.min.js. Actually, I think I spelled it with a lowercase t. And so you can make sure that it included it by refreshing and saying inspect element, and that'll bring up, or you could just do Command Option J, which will bring up the JavaScript control. And so if there's no problems in here, like if it says like, you know, can't find JavaScript, then your path is incorrect. So just make sure that everything's capitalized correctly, and you actually know where the path is. And you're including it correctly. The next thing I'm going to include is, and SRC means source, and that just tells you where it exists. The next thing I'm going to include is trackball controls.js. And again, I just want to make sure that everything's compiling correctly inside of my thing, that these things are including. And as long as you don't get an error down here, it's more than likely going to be the case that it is included correctly. So then I'm going to also include, and I'll talk about the trackball in just a second. But let's just get our stuff in there first. So source equals, and then I need my effect. So js/ASCII effect.js, and this is just someone made this. It's just another part of the enormous library that is Three.js. It's just some code that basically takes light values and replaces it with ASCII characters. And actually, I'm not even going to include the stats, so don't even worry about the stats. Cool, so we have everything that's like basically set up. We can make sure by reloading, it looks like there's no problems down here, so we're good to go. We're ready to start coding. So now we created script tags where we wanted to include files, but also the script that we're going to write is going to be inside of script tags as well. So let's start out by declaring some global variables. Now these are going to be global because we want all functions in our website to be able to access them. So we'll do var container, which will be the document object model element that will hold our canvas. And then we're going to do, and that's it because I'm not going to do stats. And then we'll do another variable, camera. So I'm separating these as to like what they pertain to. So, and we'll go through and talk about them each individually. But basically the camera, the controls, and the scene and the renderer are all kind of like the Three.js like base elements that we're going to be using in almost every single thing that we ever make in Three.js. So that'll get its own line just because I want to make sure that this is readable. And then I'm going to create the actual elements, so sphere and plane, right? So as you can see back here, or let me just open this in the browser. Open in browser. So here's the sphere and here's the plane that the ball is going to be bouncing on. So that's just a little bit of whatchamacallit, like we're building our scene out. So Cool. So we're building a sphere and a plane. So those are going to be objects. That's why they're off to the side. And then we're going to create a start, which we will use as the time that we start rendering the moment that this begins. So then we are going to call functions. So the way that JavaScript kind of goes is like whenever I define init, it's actually not going to do anything. Like if I just had this, nothing except for start is going to be given a value. So if we can see that pretty easily by just refreshing, and then we can say plain, and as you can see, it auto completes because it knows about it. But if we do that, it says undefined because we haven't given any definitions to it. And then if we do init, which is defined, it will do nothing because there's nothing in here. So the way to kind of jumpstart JavaScript is to call the function. So wherever you are going to call a function, you call it, and that will launch that function. So now if I wrote, alert, hello, hopefully this works, it should work. So it runs hello, but if I take away this function call, nothing. But if I do it down here, if I call it here, hello. So it has to, you have to call it somewhere, and the way that you call it is just to actually, without function, just call the function, basically. And we'll show more about that as we go. So let's start initializing. And it's called init because it's like the normal way of calling an initialize function. So this is going to set up our entire scene from start to finish. So first we need some width. And we're going to grab the window. So the window is this window. So there's like a JavaScript defined, as you can see, it auto-completes, and then it's got like a lot of functions on it. You can get all sorts of stuff from it. But all we're really interested in is getting the width. So this will be a dynamic width. And so anytime you open it up, it will discern what the width and height is dynamically. So if you have like a small phone, it will be a different view than a large, television or the like. And of course, there's also a height as well. So now if we save and we refresh and we say width, so these are global because they are declared outside of any function. These unfortunately are not. So these are going to die the moment that we hit this this right here, this right brace. So, but we only need these for inside of this function as we initialize stuff. Then we are going to give container a value. And this is, again, more little JavaScript stuff. Soon we'll start just using jQuery, which is much easier to grab some of this stuff. But basically, document is what is on the page. So window is the entire thing. It's like the mother of document, and document is the child of window. So document, every web page has a document, and every browser has a window. You can think of it like that. So then we're going to create element, which is a function, and as you can see, it turned gray. It's a function on document, and we're going to say div. So we're going to create a div tag, just like body, except it's going to be div. And then it's going to create that and container is now going to hold that div object. So now we can do, now we can put that on the document by the append child. Like I said, window is like the mother of document, document is like the child of window. So now we are making div the child of document. So that now will create a div, and if you go in here, refresh, inspect, inside a body, you'll see a div. But we didn't actually create that div, it creates it for us. So now we will create another element, which is a little bit of HTML and CSS, which will just kind of reinforce you know, what's going on here. So document.create element. We're going to create another div. And then info.style, so it has a style tag just like CSS, and you can just give it CSS directly. Position equals absolute. So this is just CSS. Sam knows so much CSS. If you have any questions, just ask him. Top is going to be 10 pixels. So that means that basically it'll put it 10 pixels below the top of the entire page. And then style.width equals 100%. So we want to make sure that it's 100% of the page. Info.style.text align, because this is going to just have some text. We'll put center. And info.style. Oops, actually, just inner HTML means like what's inside of the HTML tag. So HTML equals, and we're going to just put some words in there, and those words are going to be drag to change the view. So that might give it away, but later we're going to add some interaction. So you'll get to see some good interaction. And then again, just like always, we are going to append this child into the container. So in essence, we have created a container, appended it to the body tag, and then inside of the container, we're appending another child called info. So if I save this and refresh, at the very top you see drag to change the view. So we haven't, and if we drag it, you can see that it follows and it'll be centered directly in the middle. But that's not really what we're doing this for. We don't really care about CSS. We want to get into some Three.js. So first things first, we're going to create the camera. So just like any type of creation, we're going to put new, and then we're going to say perspective camera. And right now you might be thinking to yourself, how do you know that? Well, I'm looking at a piece of paper that's telling me it, but also using this stuff, you can just read the documentation. So if you want to know how to make a perspective camera, you look it up and then it'll tell you. It's pretty simple in that way. What I am entering in here is a little bit weirder, and we're going to talk about this stuff whenever we get into matrices and transforms. But basically this is saying the field of view, and it's taking a floating point even though I'm not giving it a dot. And then it's taking the aspect ratio. So those of you out there who have done film, this is basically width by height. So 4:3 is basically you know, the old version of aspect ratios. We're literally creating a camera. This 1 and 1000 is basically the near and far plane. So this is like 1 unit in front of the camera, and this is 1,000 units in front of the camera. So this is basically our Z buffer. We're saying this is 0 at Z, and this is 1. So anything within 999 units will be visible if it's in front of the camera. And we're not giving the camera, and now we're going to give it a position. So we're going to move the camera, and I'm going to actually show you what I'm doing here in real world. So basically I'm giving its Y value 150, and then I'm giving position dot Z, so I'm moving it back in depth to 500. So let's talk about this. I'm going to turn on photo booth so you guys can see me. Basically, what's happening here is, say that we have a 3D plane, right? 3D plane. Okay, and let's say that this is y of 500, and this is x of positive 500, and this is z of positive 500. Okay, so basically, and this is just infinity. Infinity. Okay, so basically, if you can hopefully see that, you can't see any of it. Okay, well, sorry about that. You can't necessarily see much of it because it is pretty hard to see. So, but what in essence we're doing is like the camera starts at origin. Everything is going to start at an origin, its own origin. But we are saying that we want to move it back in Z to 500. So first we're moving it back to 500, and then we're moving it up in Y to 150, so which basically moves it up to 150. If you can imagine, this is our point. So let's say that this is 150, right? And so we could draw a line there. And basically, x is going to be 0. Man, I wish you could see this better. Let's see if I can move over a little bit. Screwed up everything. Alright, so yeah, that's a little bit better. Okay, so basically what we're looking at is it started here, moves back 500 in Z, moves up 150 in Y. So now this is pointed this way, and if you could imagine, it's looking at this, it's looking this way up to, let's say that this is negative 500. This is its back plane. And let's say one in front is its front plane. So we can basically see all of this, if that makes sense. And the aspect ratio is this. So how tall it is versus how wide it is, if that makes sense. Hopefully you guys can see this. I'm sorry if it is very, very small. I'll try to draw all of the next stuff much bigger. But so in essence, we have created our camera and we've positioned it. So our position then, now that we have our position, we're going to make our controls. So our controls are trackball. Trackball is basically exactly like it sounds. Those old, we had all of those old mice with little trackballs, and basically you're going to move it around, but it's going to stay centered and on its side. So basically, you'll just use this, and it'll do all of the mathematics behind the scene of keeping stuff together. Let's see, trackball controls, and then we'll do camera. So you're basically giving it the camera, and you want to control. So let me just really quickly show you what a trackball looks like. browser. So if it opens, now we are just basically going around and around, but we never really change position from the center. We're just always looking directly at the center. So it's not the best explanation, but you'll understand whenever you play with it and tweak with it. So now we need to make our scene. So what you could think of is your scene is basically the container that holds all of your elements. And whenever it's rendering stuff, it's going to go through that scene and it's going to take each element and it's going to render it in order. So, you know, we've been talking about depth order and all that type of stuff. The way that you add this stuff to the scene is basically the way that it's going to render it. So it's going to, if you want it back to front, then you add things, you know, back to front to the scene. So it's basically just a really big, really nice array. Basically, you could think about it as an array. So what we're going to do next is we're going to make a light. So today we talked about lights. A point light is going to be basically is what we're going to make, a point light. And again, you may be asking yourself, how do you know to use a point light? Well, I'm looking at a piece of paper, but also if you go on to Three.js, you can see all of the lights that they have, and you can play around with them, and you can see which ones fit your specific you know, needs, and then you do stuff with it. So light.position.set. So now we're going to set a position 500, 500, 500. So this is X, Y, and Z. So I'll quickly show you. I'm going to erase this really quickly and then make it a little bit bigger so you can see kind of what it's doing. So let's say that this is our coordinate system. We'll talk a lot about this next week. So 500, 500, 500, 500, 500, oh, sorry. 500, negative 500, 500 y, negative 500 x, positive 500 z, and negative 500 y. So hopefully that's a little bit easier to see. So basically, what we did with the camera, remember, is we moved it back in space, 500, then we moved it up, and we moved it up to 150, and then that became its spot. And so it's looking this way. With this light, we're doing X 500, Y 500, Z 500. So in essence, we're moving it out to 500X, right? Then we're moving it up to 500Y, right? But then this doesn't actually show that well. And then we're moving it back 500. So in essence, I wish I could do better angular drawing. In essence, it's like right here, where this is here, this is here, and this is here. So it's like moved out in space 500, and then it's moved over and up. So it's going to point directly at origin unless we tell it to point somewhere else. So it's like pointing directly here, and the camera starts down like over here. So if you could think about it, it's like the light is right here, the camera is right here, and they're both pointed at origin. So let's give it some more stuff. So now we're doing scene.add. So scene.add is basically like for variables you say push, or I'm sorry, for arrays you would say push, but this is basically going to add it to the array, quote unquote, that is the scene. So then we're going to create another light, and by defining it another variable and equaling it to new, we basically obliterate whatever was inside of light before. And so we can reuse we can reuse everything. So 3.point light, just like before. Also, this is, if you'll remember, this is white, basically. So it's shining white light. And then, so we're going to do that for this one, comma, and then, but we're also going to add the second thing, which is a percentage. And basically, what this is going to do, like you could imagine that this is kind of like this. So we want this light to shine at 100%, by not putting anything in there. But down here, we want it to shine only 25%. So if you could imagine, here actually I'll show you like where we're going to put it in the scene. Light.position.set, and then we're going to do -500, -500, -500. Whoops. So basically that's going to be the exact opposite way, and it's kind of just going to be a halo light. We don't want to add a ton to it. Let me kind of go ahead and show you. If you've done, so you can think about this light being over here. Also pointed at the it's going to be completely under. It's -500, zen, 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 zen. It's -500, zen, zen, zen. And it's -500, so zen, 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 zen. And it's going to be somewhere here, basically the exact opposite position. So it's going to be an underlight. And it's mainly used, if you've done any like film production, you'll know that you add multiple lights, and some are spotlights, and some are ambient lights, and some are just giving you the feel of realism. As if you think about like there's a key, and I don't know. Anyway, you can imagine that this will make the colors look more real, basically. So I want to add that to my scene. Light. Now, let's make some geometry. So we'll take our sphere, sphere, and we'll make new 3.mesh. Also, you might be wondering, like, how would I know that 0.25 will make this light different from this light? Like, why didn't I have to add a 1 here to make sure that it's a 1? And that's basically, again, reading in the documentation, you see that point light's constructor takes multiple variables, and if you don't put anything, it has default values for it. So just like that, we're going to do new 3.sphere geometry. And then we're going to give it some values. So let's give it 200. So that's the radius, or actually I think it's the diameter. Then 20 will be the segments going like longitudinal, and 10 will be the sites going latitudinal, like basically east, west, and north, south. So how many segments there are, and I'll show you in just a second like what that looks like. And then we're going to give it a color, or actually we're going to give it, like we said earlier today in class, 3.mesh Lambert material, and then we're going to give it some options. We're going to say shading, shading equals 3 dot flat shading. And we're also going to give it a color just because I want to. It doesn't have it in its thing, but I want to show you. So the color will be 0xFF0000, which is a red. And yeah, so then we'll put a semicolon at the end of that. And that'll basically create our sphere. So if you read it, it's basically a mesh wants some geometry and it wants some material. So I'm just creating the geometry and the material in line inside of the constructor. So just so that I don't have to make a bunch of extra variables and whatnot. You know, I would say, like, until you really understand what's going on, you should make new variables. And the simple way to do it would just be to take that out of there, say var geometry equals new 3 sphere geometry, and this var material equals new 3 Lambert material, mesh Lambert material, and then you would just put geometry. So I'm just like skipping that step basically, if that makes sense. And again, you might wonder, how did I know to put geometry on this side and mesh Lambert on this side? Again, it's just, you know, looking at the documentation and looking at examples, which are, you know, abundant. So scene.add, and then I'm going to add my sphere. So right now I want to make sure like everything is working. Now that I have stuff in there, let's see what it looks like. So basically I'm going to jump ahead a little bit and I'm going to say render equals new 3. And again, you'll get very used to typing that new keyword because it is used with everything. And then we'll say canvas renderer. You can do any type of thing. If you already have a canvas, you just do WebGL render, but we don't have one, so this will create the canvas and create the WebGL at the exact same time, and then render will you know, contain that stuff. So I will then do render dot set size, and I'm going to give it that width and height that I originally had from way back up here. And then I'm going to say container, which is our main container, dot append child, just like always. And then I want to use the render dot DOM element. So again, you might be asking, well, how did you know that render has a DOM element? Well, it's because like this is the protocol for adding a DOM element, is basically having it created, setting the size, and setting other attributes after that, and then adding it to the container or the document, whichever you're using. So if I go back here, I will get probably problems. So, oh, right. And then right here at the end of this, you'll do render, which is another function on the canvas renderer, and you'll give it the scene and the camera. So you can imagine that you'll have a lot of scenes and a lot of cameras, and you can easily render whatever you want dynamically. So if I render it, it gives me my sphere. As you can see, there's 10 segments this way and 20 segments this way. Basically, a segment is a line. You could think about it like a line. It's creating these lines. So if I change the segment, if I change the segmentation to, let's say, 100, it will create more lines around it. let's say that I want to change this to 100. And again, this is like really easy, just I'm reloading the page. And then if I'm like, I don't want 3 flat shading, the reason that we're going to use 3 flat shading is because of something that I'll get to in a little bit. But basically all I have to do is take it out, save it, yeah, and it'll render it correctly where it does that vertex lighting rather than fragment lighting. So let's put it back in though because I want it to do it. Let's check it by reloading, and there's the flat shading again, and then let's change these back to 20 and to 10. And this might seem like, why would you make it so ugly? Well, it's going to give a lot more difference between these segments, so the ASCII will actually become different as well. But as you can see, we're getting light from over here, just like we talked about. And if I can find Photo Booth, I'll explain that basically we're looking at our sphere right here. So this lighting is hitting it right here, our camera's right here, and basically you can see that that's what's going on. So that's what I expect to happen, and so we're on the right track. Now, we want to do an effect, so let's get rid of this because we're going to create an effect. Actually, before we do that, we want to also use our plane. We want to create our plane. So our plane is here. We'll give it a new 3 dot mesh and a new 3 plane geometry. And the plane is basically width and height. So a plane isn't necessarily 3-dimensional. It can be, but you'll mostly create it by 400 tessellations by 400 tessellations, or width and height basically. And we will then give it some material, which is new 3 dot mesh basic material, because we don't really care about the light hitting this. We don't really care about the light hitting it. So in there, we're going to give it some color, 0x, and this is arbitrary. Again, I just chose it, or actually the example chose it. But you can tweak around with it very easily. And we will give it a position. We'll do some positioning to it. Dot Y, and we are going to move position to -200. So it's going to be from the origin down 200 units. So then we'll make a rotation. Rotation, and we'll talk all about rotations in a little bit. And we're going to give it a rotation of basically, I believe, math.pi divided by 2 is 90 degrees, I'm pretty sure. But basically we want it to rotate around 90 degrees. So then all we have to do is scene.add plane, and let's undo that. And then you can't really see it, but you can kind of just get a glimpse of it under there. You'll see it a lot in just a second, but for right now, it's kind of hidden behind the stuff. So yeah, all right, cool. So now let's talk about the effect. So here we created a renderer, and then we appended the child to the document just so that we could see that everything was working correctly. But I want to take that off, and I want to also take this off. and instead I want to get an instance of the effect, which is 3.ASCII effect. And what we pass in here is a renderer. So you could imagine that, like, because this is an effect on the way that we see things, I need to send in the renderer so then this effect can do things to the renderer behind the scenes. I don't ask questions, I just do what I'm told. I want to set the size, and I will set the size to width, height. And now I have this effect, but I need to add it to the container. So pin child effect instead of renderer, because we now want our renderer to be created, or we want to render from the effect. So we're going to add this DOM element, and if we do that, it may or may not work. Oh yeah, and then I have to render. So effect dot render, and then I'm going to give it the scene and the camera just like I did for the renderer. So, and there we have it. We have this ASCII effect. So as you can see, like, this light is making these all asterisks, and the next level is going to be these hash marks and percentage, and then the back level, or the closer to black, is going to be these at signs. So you can see kind of a gradient across it. Looks pretty neat. But you know, it's still kind of boring because we're like, and you can also see there's the plane down here with you know, the periods, because it's very, very white, or you know, it doesn't have any, it's not in shadow. So now what? We want to add some motion to this, and we want to be able to move around it. I mean, why did we make the control if we can't even move around it? If I click, I can't do anything. And I told people, hey, you can drag to change the view. So let's add those things. So how do we add those things? Well, whenever you have all of this correct, what we're going to do is we're going to add a listener. So we're going to say window dot, and this is like basically, hey browser, add event listener. And you might be like, how do you know what event listener to do? And you know, I know because I looked it up. So all I have to do is just resize. So basically the event is resize, and what I want to give it is a function. So I'm going to make a function, and I know what it's called, but it's going to say on window resize. So on window resize, and then false. I can't remember exactly what false is, but I could look it up, but I'm not going to right now. But that's just kind of normally the way that it goes. So now I've created this event listener, but I don't have the actual function. Well, I need to create a function. So I will create a function called onWindowResize, and it's not going to take any arguments. And what it's going to do is it's basically going to reset the camera, and it's also going to reset the position, and it's going to totally you know, reset all of the view things basically. So what I'm going to do is I'm going to say camera, and remember I can say camera here because it's a global variable, not created inside of any function. So it's a global variable, so I can still use it even though we've already created it up here. It now will have that forever. So I'll say camera.aspect, which again, like I said, we set the aspect right here, but we don't have that aspect anymore whenever the window resizes. So we'll say camera.aspect equals, and then we'll call these window.innerWidth and inner height again, because the window will know even during resize what its inner width and height are. So I will create it like so, and that will just update the camera aspect ratio. So if I did that, and I return, and if I do this, even though you can't really see that it's changing much, it's changing the aspect ratio. But why didn't it change what it looks like? Because I have to say camera.update projection matrix. So we're going to talk a ton about projection matrix. Don't worry about it right this very second. Just, again, write the code down. But more what you should take away from this is that we've set this number, but maybe the rest of the camera class doesn't know that we've set this number. So what we would have to do, like there's a helper function, and you'll see a couple of these throughout this tutorial, is basically a helper function that says, hey, if you update anything, go ahead and call update so I can make sure that the rest of the class knows that this is the new aspect ratio. So I call it right afterwards, and if you see, if I return, oh, it's still not doing it. What is the... it's because I didn't also change the render size. So up here, I set the render size with width and height. So it still has that original width and height. So we can't change anything until we set the new size, which will be window.inner width, inner. And you'll see that like most things will be x, y, and or width and then height. Most programming things in general, whenever setting size, will be x and y or width and height. And so that's what I'm estimating, and then I have to change my effect. So you basically, what I'm doing is creating an update function that will be called anytime the window is resized, so that I can basically change all of my size variables dynamically, which is pretty neat. You know, you can. It takes a little bit. So now if I size it, even though it's, why is it not doing it? Why is it not doing it? Inner width and inner height. Oh, right, because I am not rendering it. Right. So I'm going to take this out of here. And what'll happen is whenever I reload this, you don't see anything. But whenever I do this, now you see it because it's rendering it every single time you resize. And it's also changing the center. So that just kind of looks nice. You know, we've done it for this and we're doing it for this. So it's just like, it makes the website much more dynamic. And you can work with these any way you want, but that's kind of the way that I work with them. So I'm going to delete some of this other stuff. So now we're like, cool, it's more dynamic, but it's not animating. How can we animate? Well, we have to create another function. And that function is going to be called up here right after initialize, because we want it to go initialize everything, and then we want it to animate everything. So down here, we'll call it function animate. So these are just general terms, and it's not going to take any arguments into the function. You could if you wanted to. And then we're going to say request animation frame. So this is like some backdoor JavaScript. And then it's kind of like the add event listener. Whenever the browser decides that it's ready to start showing another frame, you say request animation frame. You send it a handler, which is basically this function. So you send it this, and so it's kind of going to be recursive called. So it'll be like, it'll animate its first frame, let's say, and then the very first time that the browser is like, cool, I'm done with that frame. Now what do I do for the next frame? Well, oh, I have this function here, so I'll just run that. And so every single time, you're basically giving itself this new animation frame. So you could imagine that you could actually set up a really complex kind of scene dynamic where you have a bunch of scenes, and like after it's animated, let's say 45 different frames, then you'll want to give it another handler that's like animate scene 2, you know, so you could take the viewer on, you know, multiple different you know, stories or whatever. So it's just a very simple function, request animation frame, use this function, which is animate. And then down here we'll say render, which is going to be another function that we are going to create in just a second. And actually we're going to create it right now. So this is a very, 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 very simple function, which basically just says call myself whenever you're ready for a new frame and also render things. So down here, let's create this render function. So the reason that we're making all these different functions is that I could decide like later that I want my render function to work differently, or I want it to be something other than what it is, and all I would have to do is just change the inner body of the rendering method, and I don't have to change any of animate, I don't have to change any of on window resize, even though it's not really calling render. But you could imagine that like by encapsulating this this inside of a function, I'm actually making it so that I can change it very easily without changing it all the way throughout my document. And we'll see that with some object orientation that I'll show you in just a second. So, render is going to create a timer, and it is going to take that time that we got at the very beginning, start, and we are going to use date.now, and we're basically just creating an incrementer. So this just increments, and it'll use how much time since the last time we dealt with this. And what we're going to animate is going to be the sphere dot position y. So we're going to make a bouncing ball. So a ball goes up and then down, so y. And we're going to use math.absolute because we don't want to go negative. So this will always be between, well, we're going to go through this, but it'll always be positive no matter if the number inside of this is negative or not. And then we're going to say math.sign, and what's great about math.absolute is that sign goes between 1 and -1, but now it's going to bounce because it's going to go 1 to 0, and then it's going to, even though the sign is going to be, you know, negative 0.0001, negative 0.0002, it's going to actually be translated to positive, so it'll bounce. It'll be like 0.01, 0, 0.01, 0.02, 0.0, you know, on and on. So it'll always be positive, no matter what so, and then we're going to use, this is going to increment, so we'll get a constant new value times 0.002, and these are magical numbers, a lot of people call, because it's like, how did I come up with 0.002? And there is no answer to that. You just tweak around with numbers, and then make sure to label them whenever you find the number that you like the best, because otherwise you'll come back to it and you'll be like, why the hell did I pick 0.002? And basically the example is just telling me 0.002 is a good number. So then we're going to rotate it, rotation.x, and we'll do timer times 0.0003, so that'll be a very, very slow rotation. And sphere dot rotation dot z. So it's basically going to rotate across these two axes at the exact same time, one a little bit faster than the other. But this will give us like a good, you know, you'll see it in just a second, it'll give us a good thing. And then we want to update the controls. So these controls, like, you can see that we really don't even have to do anything, and we will get a ton of functionality out of this. And then we're going to render. So effect.render. So I had it up here, and Now I'm going to bring it down here. So cool. So let's see what happens. And voila, it is bouncing. We have a bouncing ball, and also we are able to go around it. We're able to go above it. And that's the trackball. So you can imagine this is like the mouse pad. So it's going to stay right where it is, but we can go all around it, and there's a lot of different weird math that goes into this. So you don't have to think about that math. It just like creates this really epic thing. This is kind of the way that I made the front page of the inner 3D programming .heroku.com page. And so you can see that this is hitting it. You might be like, whoa, how is that hitting it? Well, what we did up here was if you'll remember, is we put the plane's position at -200. Well, we're doing this by multiplying this by 150, which is basically 0 to 1 times 150 every frame. And that's basically going to, its lowest point will be 150. It'll move down. So 150 plus the diameter, which is 100. I might be going totally nuts over this, but basically the diameter, which is 200, means the radius is 100. I think I'm getting this correct, but basically, sorry. And also you can see that like over here, really quickly, you can see that over here is the bright spot, and back here is kind of just a fill light. So that's why it's not as intense as this part over here. And that's more so that we can understand what's going on. But if I do this, we will be able to, and I instead do container .append child render .dom element, and to take this out, and I can see it as it is without the ASCII effect. And you can see that, so like, let's say that this is 100 radius, so 200 diameter and 100 radius. Whenever I'm multiplying this, which is going to, again, go between 0 and 1, multiplying it by 150, we're going to go down 150 and go up 150. So that's why it gives it this look that it's bouncing. And the X and the Z are rotating it, which you can see pretty clearly here. But yeah, so now you might be like, awesome, we did it, you know, we made it, it's awesome. And it is totally, totally, totally awesome. What did I do? Oh yeah, so save. And then let's reload it so that we get that cool ASCII effect. But you might be like, well, how do I make 1,000,000 of these? Well, it's quite simple. Yesterday, as you saw, I created some objects. So I'm going to create an object, and it is going to be, its function is going to have diameter. It's going to take diameter, which is a number, and it's going to take segments, which are these things right here, 20 and 10, and then it's going to take X, Y, and Z. So if I do that, now I say this, so I'm basically attaching these new things, and I say sphere. So this dot sphere, basically I'm saying this is now going to have an object, or a variable called sphere, and what that sphere is going to be is, wait for it, this. So basically I'm saying I want this object to hold an object inside of it that is a 3 mesh, and I want its diameter segments X, Y, and Z to be filled in. So all I have to do is say diameter X, or actually, sorry, segments. So I'm going to make it somewhat simple. We'll not have 2 different segments. And then I'm like, okay, cool. Well, what about its position? So let's set its position. So I'll get rid of that. And I'll do, and now after this, I will create a function. So this dot set position is going to be a function that's going to be anonymous, although it's going to become you know, an actual named function. And I'm going to give it x, y, z. So I'm actually going to take these out of here because I can just call x, y, and z set position, or I can just call set position on sphere, and it'll set this dot spheres dot position dot x equals x, right? This dot sphere dot position dot y equals y. This dot sphere dot position dot z equals z, right? Because I'm getting these in here, and then I'm using the sphere that I know that this is another object. So this is basically, sphere right now is a sub-object of my big object, which is sphere. So let's say that later I want to add 25 spheres, or I want to add like specific Mesh-Lambert material that can be more dynamic than it is right now. I can do all that with my sphere class. So I'm basically saying this object has a sphere which has this inside of it. I hate the word this in this scenario because I can only say this whenever I'm starting to say this. Anyway, so this also has a set position function which will take this is sphere and it will change the position x, y, and z dependent upon how I do it. And I'm going to do or right here, that's the or, 0. So it's going to basically be a Boolean statement right now. What that is going to be good for is sometimes I don't want to set each and every single position. And so instead I can actually just do or this dot sphere. I can just make sure that if I call this and I don't want to set y or z, it'll know that x is nil because it didn't get, or sorry, let's say that I'll come back to explaining this because I want to show it how it works. Position dot y. Basically, I'm just resetting it if I don't set those specific variables. So position.z. All right. So that'll set position, and then I can set rotation by accessing it, and I'll show you all this type of stuff. Actually, let's not talk about this. Yeah, let's talk about this. Okay, so now down here I'm like, well, I don't have a sphere anymore, but I want to add more spheres. So I want to add more spheres. So let's put this on its own place, and I want to have actually an array of spheres. So the way that I'll add a bunch to the array is through a for loop. And we will say, I'm not actually going to call it things. Maybe I should call it. No, I'm not. So let's take that out, let's take that out. And let's say that I want to add 10 spheres. So what I do is I say sphere, actually let's make sure, I'm like naming all these terribly. So let's call the array of spheres, spheres. So now I'll say spheres dot push, which is the way that you add something into an array. I'll do new sphere, and then I will say, let's see, new sphere, and I have to make sure, oh, this is diameter and this is segments. So I'll say I want these diameters to be 100, and I want these segments to be, let's say 20. So that'll be used for both of the segments and the other stuff. So actually, I do want to add these here. So what I'm going to do is I'm going to add this in here, this dot sphere dot position dot x. So I'm going to move this across x. So I'm literally just saying that I want x to be a part of this. And the only reason that that works is because I know that I want to change, whenever I build this thing, I want to change it immediately. I want the x. So the only reason that I know that is because I know it. I will explain that if I can, but basically I know that I'm going to, like, if this is the y coordinate and the z coordinate is coming towards me, like is coming out of the screen, then the x is what I want to immediately transition. So whenever I create 1, it'll be on 0, and then I create 2, it'll be on 1, and I'll create another one, it'll be like, basically I want to move all these over. So that's the reason that I'm actually defining my class in this way, is basically I know that I want to change x immediately, but I don't necessarily want to do it by setting the position. So that's just one of those like design things where I know, maybe you do, maybe you don't, but the way that I'm going to do it is times 50, which is half of the diameter. And so the first iteration will be 0, the second iteration will be 50, the third will be, well, it'll be 0, 1, 2, and the 2 value will be 100, 3 value will be 150, and so on. So it'll move all of these spheres over so that I can see them. Otherwise, they'll all be drawn on each other. So, a lot of crazy stuff, but just hold on, you'll see where I'm going. And then I want to add spheres, this element that I've just pushed on to the scene, right? So what does that look like? What did I do wrong? Probably did something very wrong. Let's see. Undefined is not a function. So what did I do here? Let me just really quickly check. Okay, so this is what I did here. I'm just going to copy and paste it, and I will explain it, basically. Instead of creating this set position thing, I'm going to go back to the old way and just do this. So basically, this is constructing an element, and that element is a sphere, and then on that sphere, this is the constructed, what I want the values of x, y, and z to be. And again, if I don't put in x or y or z, it will just default to 0, because it'll be x will be nil, so it'll be if nil, then 0. So I know that's kind of weird, and I can explain it to you more if you need it, but let's just take it like it is, and I will reset it, but it still says that it is not a function. Let's make sure that I'm adding it appropriately. Oh, right. So spheres dot sphere. So spheres I dot sphere. So what's happening here is that scene doesn't know what an array of spheres is, and spheres is my type. So scene 3JS doesn't actually know what my type is. It's like I don't have any idea what that is. So what we really want is just the sphere member variable, and hopefully, if I do it that correctly, no, it still doesn't want to do it correctly. So I'm just going to pull this directly out of my code. Sorry about this. And basically, there we go. Damn it. I'm sorry, guys. Okay, so why is this not working? I'm sorry, guys. It does work here, though, which is weird. Sphere. Oh, right, because this is nothing, and yeah. So, spheres.push, new sphere, spheres dot sphere. All right, well, in essence, I apologize. I will make sure that I can teach this better next time, but basically what we can do is now use this as an object, many different spheres at once, and we can hold inside of those each of these different positions based upon where they are. And so in essence, if I run this, which does work for some reason, it will be like this. So I've got 10 spheres back there, and you can see it, and they kind of disappear because they're going past 1,000, but yeah, it's got 10 spheres. They're all being rendered, and that is basically my tutorial. Hopefully you got some stuff out of it. Hopefully that last part didn't totally crash everyone, but please ask me any questions on the forum and or email. Otherwise, I will see you later. All right, talk to you later. Bye-bye.